Welcome to the wild world of cephalopods.
The Cretaceous Tertiary extinction event is one of the most talked about extinctions in history. It not only wiped out all of the dinosaurs, but also the marine reptiles and the ammonites from our cephalopod group, our beloved cephalopods. There has been much debate as to how the extinction event occurred. The two most accepted theories are an extraterrestrial impact or a volcanic eruption. There is lots of evidence for both theories, making it hard to decide which one is really true. So, all we know for sure is that something had to happen in order for so many families of animals to have gone extinct, especially our beloved ammonite cephalopods.
Each cephalopod subclass is defined by the various shells and body plans that occur within them. These three subclasses will be broken down eventually, but for now, here are the basics that apply to all cephalopods. These unique mollusks are characterized by their foot, which is located in the front of the head and the mouth, thus the name headfoot. These feet were actually tentacles, which could vary in number and length and were used during feeding. Behind the tentacles are the eyes. Cephalopods are known for their complex and very well-developed eyes, head, and nervous system. The body sizes of cephalopods had a very large range during and around the time of the Cretaceous and Paleogene boundary event. This range was anywhere from 1 centimeter to 1.7 meters in diameter. Another characteristic cephalopod body trait is the use of jetting as a form of locomotion. This is achieved by taking water into the mantle cavity, closing off an entrance valve, and then forcing water back out through an opening called the hyponome. In the case of nautiloids and ammonoids, they didn't have any sort of fins, so this method and gravity are their primary sources of movement. These shelled cephalopods also had chambers in their shells, which they filled with gas and liquid. The gas and liquid was then used in achieving a more neutral buoyancy. Thus, the cephalopods wouldn't sink as fast and wouldn't need to use as much energy to stay at a safe depth. The first subclass is the nautiloids. These cephalopods are characterized by involute shells that are broken up into chambers, separated by walls known as septa. The body was located in the largest chamber, but a fleshy part called the siphuncle connects it to each of the progressively smaller chambers. The next cephalopod subclass was the coleoids. These animals most closely resembled modern-day squids and octopi. These cephalopods didn't have an external shell like that of the nautiloids. Instead, their skeleton was internal. Over a long period of time, they evolved so that the shells were completely covered with skin, and eventually covering began to occur while inside the egg. The most obsessed over of all the cephalopods are the ammonoids. These cephalopods had planispherical shells that were both involute and evolute. Ammonoids had very prominent sutures, which were connected to the inner shell by the septum. These sutures of ammonoids were sometimes very complex with a series of curves known as saddles and lobes. Over the course of the period, many ammonoid shells uncoiled and evolved into what are known as heteromorphs. In addition to this shell curvature, the sutures also evolved over the course of the Cretaceous period. Some became much more complex, but toward the end of the period, many also evolved into much more simple formations.
Cephalopods, of course, always remained marine animals, as they were one of the few classes that never branched out to the land, while all cephalopods did live in the ocean. Different kinds of cephalopods lived in different areas. Some ammonites, shell cephalopods, would use their shell and air-filled cavities situated throughout their bodies to float throughout the open ocean. However, other species of ammonites, those that generally had much larger shells, would keep to the bottom of the ocean and catch their prey and reproduce at the sea floor. Prothero. 304. As time went on, cephalopods evolved different characteristics, such as adapting new habitats to larger size and thickness of shells in order for them to survive against larger predators. These carnivorous creatures would use their tentacles located above their head to constrict and trap their prey, and then bring it inside their shells to an interdigestive cavity, which would transfer the prey into energy. In summary, the Cretaceous Tertiary extinction event brought a significant change to the class Cephalopoda of the 3 subclasses that existed in the time nearing this event only. 2 remained. This brought on many evolutionary changes affecting most aspects of the animal. Without these evolutionary changes, who knows what the cephalopods would be like today?